So interpreting and analyzing histograms. So this would have been what we worked on. You should have worked on Wednesday. So Wednesday, so if we're looking at these, there are some of these in EOC release questions. So you will probably see one or two. I'm a big fan of the EOC, and the reason I mention that is so hopefully you turn on your like, oh, I'm watching, because that's going to be one of those style of questions I'm going to see. Because I'm a big fan of like knowing when you walk into the EOC that you are going to have 5 to 10 questions in the bag. Like, you know, you're going to get those right. Because if we're being honest, a state given test, they'll throw out questions that make no sense. And I can teach my little butt off, and we probably will not cover everything that they potentially are going to ask you, because some of the questions are going to be like test questions. They might not even count. And another thing I would like to say up front is to pass the EOC, you really only need like 10 to 15 questions. It is probably actually less than that if you want a 60 out of the active and inactive to pass. So if we know there's going to be one of these questions, I can promise you, as long as you like highlight or star or make notes to yourself mentally, these questions are going to be there. I can show you at least 8 for sure that you're going to see, and probably more than that because they usually duplicate. So basically, if you're taking really good notes and paying really close attention to when I say that, you're guaranteed a 60 on your EOC. Like, you're going to pass. And then after that, just learn the math and you'll score higher. But there are going to be some of these data analysis questions. For histograms, like I said, there's 1 or 2. But let's get to it. So histogram, old school. So these are going to be your bars. Histogram versus a bar graph is because they're bumped together and they have your intervals or domains to 57 to 59, 60 to 62. So it's a set. Sorry, lots of things going on Google. So which group has the most students and how many are in the group? So most students, this is your number of students and height. I would say your biggest call out to histogram type problems is making sure you're reading your labeled axes correctly. So like that, you know, this is number of students, this is height. So personally, if you can slow your brain down, as soon as you see this, before you even get to the question, I would say, okay, number of students, height. So that means like 25, because these are counting by tens. Of the students are between 57 to 59 inches. So pay attention to that as well, because a lot of their questions, again, this is repeat math, so they're trying to stump you up. A lot of their questions, maybe it'll be in feet, not necessarily in the histogram conversation, but paying attention to that, you may have to convert things from inches to feet or feet to yards and so on and so forth. So again, just some test quiz taking skill strategies is to really look at your graph first. So which group has the most students and how many are in the group? So this is our number of students. We want to go all the way up. So 63 to 65 inches has the most. It says and. That's another thing I want to make sure that you do. I would say read the question, answer it, read the question again. Because that is a big thing in Math 1. You guys seem to just jump into the deep end of the pool and no swimming, answer the question, then run off. So we answered half of it, but we didn't answer the whole thing. So in this case, you would only be getting half credit. So how many are in the group? And that's that 100. So 100 students. And as pain in the butt is writing all those letters out beside it, inches and students. It is a quality check. If you do that, it keeps you from, again, jumping in the deep end with no swimmies or running off and not answering the question appropriately. So what is the range of the height recorded in the histogram? So range, remember, is the difference between your max and min. And in this case, it's somewhere between here. So it's going to be from 57 to 74. So 57 to 74 inches. So for the whole thing, all of this data falls somewhere between your lowest number and your highest number. All right. This is super, super on our level. Those first couple of questions may have seemed pretty easy, hopefully at this point. So how many students are at least 69 inches tall? So we are still looking at the same graph, number of students, height in inches, student heights. So how many students are at least? So at least means it's 69 or more. So 69 or more, or higher, or taller. So if we go to 69, which is going to be right here, and then we want to go this way, 69 or more. So that means I have 30 students here, and I have 10 students here. This is the 100 we already talked about. So 30 and 10. So there should be 40 students are 69 inches or taller. Is it possible to tell the height of the tallest student? No, you can't, because you don't know that there's actually a 74. We just know there's 10 people that fall between here, and your intervals have to be the same, like an accurate histogram. So 57, 58, 59, so this is 3, 60, 61, 62 is 3, 63, 64, 65 is 3. So they had to make this 72, 73, 74. There's no guarantee that there is a 74. All 10 of these people could be 73. All 10 of those people could be 72 inches tall. So no, you cannot tell from this. If the data was put out in a frequency table, a list, a dot plot, or any of those, then you would be able to, or a stem plot, any of those other different representations of data, then you could. But in a histogram, you cannot give that kind of detailed answer. All right. So another example. Which interval has the most states? So it's number of coasters, roller coasters, number of states. So interval has the most. You're going to look for the highest bar. So this is 34. This is 0 to 9, 10 to 19, 20 to 29. So they are all matching. Luckily, in a virtual class, you're not going to have to build these yourself, but you do just want to know that these always have to be the same domains or intervals, like so the same amount. Most states would be 0 to 9. So 0 to 9, roller coasters. It's 34 states, which is just extra, telling too much, but sometimes that's good because then you get in the habit and you don't miss out. What percent of the states are in this category? So to do percents, that means 34, the number we're talking about, out of total number of states. So I have 34, I have 8, I have 2, 2, 3, and 1. So 34 plus 8 is going to be 42, 44, 46, 49, 50. So all 50 states are in this table. So 50 states total. So 34 divided by 50 is going to give me my percentage. I don't want to guess and mess that up. Grab my calculator. 34 divided by 50. So that's going to be 68% of the states. So 68% of the United States are going to have 0 to 9 roller coasters. Still talking about roller coasters. Why is there a jagged line on the vertical axis? Because there's a big jump. So that means we just brought this down. So sort of like changing your window on your calculator, if you've done any practice with TI-84s or 83s, it just brought it down so you could see it. Just brought it down so you could see it. And actually that means our percentage is wrong. I completely just missed that. No, it's not. Just kidding. Because we used 34. But the zigzag means we just made a virtual jump from 10 to 34, whereas we were counting by twos. We then counted by 24. So that just notes that there should be a lot more lines there. How many states have no roller coasters? How many states have no roller coasters at all? You can't answer that question because you don't know. In this 0 to 9, these 34 states could all have one. They could have 1, 2, 4, 7, 8, 9. They could have any of those numbers in there. It's not enough information. So not enough information. Because you don't actually know what this data set looks like. You just know the visual representation in a histogram. So we can't answer that question. Median of the data, we're going to get into that the next day. Median. And now we're going to talk box and whiskers. All right, box and whiskers. These buggers are definitely going to be on your EOC. You are probably going to have 2 or 3. So I'm going to kind of make this a long explanation. This one, I believe, is an actual EOC release question. So this is one of the ones that the state says, make sure you can do this. So the number of donations each day, drop-off points, the data is given. So we have our data. In a calculator, you can type this in your L1 in TI-84. How many of you guys have TI-84s? or are going to be using Desmos. If you have a calculator, let's put a C in the chat box. If you're going to be planning on using Desmos, put a D in the chat box. So I'm looking for 9 responses. Come on, guys. Yep. Because I'm trying to make sure that I give you the right videos. Desmos is going to be embedded in your EOC. And from what I could tell, it is absolutely like full interactive Desmos. Like you can do everything during your EOC and Desmos during the calculator active portion. So that's 3 people. I'm waiting on 6. I need to know if you're going to use calculator or Desmos if you have at home. Yeah, you'll get a TI-84, like the one we had on like you've had on campus in the past. That big, chunky one. The one I have is kind of not the right kind. But so Desmos. Okay. So then that's only 6. Okay, yeah, Logan, absolutely. I will post, Logan, just so you know, probably because the way it's looking at the moment from y'all's chime in, I will post most of your TI-84 instructional stuff in the extra help section. And if I don't post something and you want it, just holler and I will send it to you and find it for you. But I want to make sure that we're using, like I said, our time wisely, and I show you the right way to get to those right answers. Most of these are going to be calculator active questions anyway, or Desmos active questions. Taquan, are you using Desmos or are you using a calculator, babe? Elijah, Desmos or calculator? Okay, so you do have a 2, yeah. Okay, so hopefully you heard me say that I'm probably going to put those at the bottom of our page when we are doing lessons, just because you guys are the minority, at least of this group. I'll send in the survey on Friday. I'll try to ask around and see if I get better feedback from the whole class and everyone. But otherwise, most of our instruction will be geared toward Desmos. And if you have questions, just holler. So, looking at this guy in Desmos, I think I might have posted it for tomorrow's work to be able to build these. If you go to Desmos, you can type in box plot, open parentheses, and type all of this in, and it will do it for you. It will draw it for you. You can click for outliers, which you will learn about tomorrow as well. And I'm just sharing you with this with you now because you showed up to class. And that's what showing up to class is going to do, is get you a little ahead so you don't have to read every detail or you won't miss anything. So use Desmos to your advantage. I did watch a lot of kids this past semester because I gave the Math 1 EOC on campus in Pinecrest. They were using it. The people who felt the most confident when they were done were using Desmos and their calculators to death. So make sure you use them. Otherwise, by hand, though, we would put these in order. So 1, 2, 3, 4 twos, 1, 2, 3, 4 twos. And then I have 1, 2, 2 threes. And I cross through my data, which is getting a little harder virtually because it's not written down, but just to make sure I don't miss one, because that's going to be your biggest oops, because if you miss one, that definitely changes the game. So 3 5s, 2 7s, and 2 10s. So our min in our 5-number summary would be 2. Our max is going to be 10. Our median is in the middle. So that means ultimately, if you wanted to do this, that means 2, 10, 2, 10, 2, 7, 2, 7, 3, 5, 3, 5. So this is our middle. So our median is going to be 4.5. And then to find your Q1 and your Q2, you're going to go from here. So 4, 2, 3, 2, 3, 2. That's our Q1. Same thing for the other side. That's our Q3. And that's your 5-number summary. So our range, again, just touching back on all the things that we've covered in the last couple of days. 10 minus 2. So range is 8. IQR, so interquartile range, is your Q3 minus Q1. So that's 7 minus 2. And that's going to be 5. And then our mode would be the only other thing that I can think of at the moment off the top of my head that they ask about. And that's the term that happens the most. And you can have more than one mode. But in this case, it is 2 because it happened 4 times. So that would be your most basic question. Hopefully you've seen those before now and are pretty comfortable with doing these things. Maybe IQR, if I remember correctly. And it's just a remembering of the vocabulary. So IQR again is Q3 minus Q1. So we're going to look for one of these graphs needs to start at 2. They all start at 2. Needs to end at 10. They all end at 10. So min and max don't help us much. Our median needs to be at 4.5. So these are counting by 2. So this is my 5 mark, my 5 mark, 5 mark, 5 mark. So B we can cross out because our median is at 5. So now we're down to A, C, and D. Our Q1, which should be the first line of our box right here, we're looking at these, is at 2. So this one's closer to 3, so B's still out. D's at 3, so it's out. So we're now down to C and A. And the differential factor is our median is above, sorry, I missed that one, is above 5. So it's got to be A, knowing our 5-number summary. Now, conversationally as well, and this is getting a little ahead, but just to add some things, remember that these are all 25%. So each one of these, no matter what it looks like. So looking at A, this is going to be 25% of our data, 25% of our data, 25% of our data, and our other 25 is like right here. So 25% of the data, 25, 25, 25. Same thing, 25, our other 25 is right here, 25, 25, 25, 25, 25, 25. And all of those box and whiskers, not terribly different, but they are not the same proportionally. So the biggest call out in my Math 1 classes in the past is to remind you as many times as possible, don't overthink what it looks like sizing wise. Know that in a box and whisker it's 25, 25, 25, 25. And that's because they're going to ask you things like what percentage of data in this set is above 7. And so above 7, depending on which one, actually all of these are at 7. So this is 7, 7, 7, 7. So 25% of the data is above 7. So those are kind of the percentage questions that you will be expected to use. That one could actually theoretically fall in a calculator inactive portion of the test because you don't have to really do any math. All you have to do is remember that all 4 sections are 25%. So if I asked for graph B, what percentage of your data falls below 5? So below 5 is the question I'm asking. That's 2 chunks, so it's going to be 50%. As soon as I see a box and whisker, usually I will put 25, 25, 25 on all my sections just to make sure that I remember. And then it's easy. How many 25s do you have? And think of them as quarters because money is usually easier for most of you to do quickly. And you like to do quick math. So that's going to be your box and whiskers. And 5-number summary after that one. These are super big EOC level. So comparing to. We're going to get into this much more in depth next week, the actual focusing on comparing. But again, you showed up and I want to show you it's not any different than doing one. It's again, just the conversation piece and the in-depthness of the question, but the skills are exactly the same. So we have test 1, we have test 2. The blank are the same for both tests. So our min for test 1 is 62. So we could do min is 62. It looks like our Q1 is 74. Median is 78. Q3 is 84. And our max is 91. And that's for test 1. And obviously you can read it. I'm just writing it out so that way you know exactly what I'm looking at. So min is 71. Q1 is 80. And I said that because just so you know, I'm not expecting you to necessarily make a list out to the side. You know what you need to do to get questions right. Like I know that I need to stay super extra over organized and neat or I miss them. Because usually my dog barks or a student asks a question or something happens and I lose focus on what I'm talking about. So the blank are the same for both tests. So if I'm looking at the mins are not the same, the Q1s are not the same, medians are not the same, Q3, the max test score is the same for both tests. So the maximum which they'll also call the upper extreme. Vocabulary is a huge deal in Math 1 because, like I said, the computations are the same for math or 8th grade math, but they'll ask it with different words or ask it in a different form. So upper extreme is maximum. Also, the word max could be asked. The highest test score. The median for the second test, and that's again just asking you if you know what this bar is, the median, because it's in the middle, is 84. And then it's blank, then the median of the first test. So that means compare them. So 84 minus 78 means it is 6 higher. So it's greater than the median of the first test. So test 2 has a higher median than the first test. So hopefully you're seeing it's really not computationally much different when you have 2. It's just making sure you're going slow enough and paying attention to what the question is asking. The blank for the first test is the same as the blank for the second test. The blank for the first test is the same for the blank for the second test. Logically, it's not going to be max because we already discussed that. So let's discuss range and IQR. So range for test 1 is 91 minus 62. And that's going to be 29. Oh, sorry for the shakes. Range for test 2 is 91 minus 71, which is 20. So those are not the same. So then let's talk about IQR. So IQR, which is Q3 minus Q1. So for test number 1, it's 84 minus 74, which is 10. For test number 2, it's 88 minus 80, it's going to be 18. And I don't see anything else. Oh, I got one. How about the 84s? Those match in their graph, but they're different things. So the blank of the first test, the Q3, which would be your upper quartile, is the other word they'll use. Upper quartile, Q3, is the same as the median for the second test. So the middle score for the second test is the same as the middle of the upper half of the data. So remember, this is the middle of upper half. So middle of the upper half. So the scores for the blank are more spread out than the scores for the blank. So it's test 1 or test 2. Which one has the largest spread? So that's really discussing your range and your IQR. For range, our largest is going to be number 1 has the largest range. But for IQR, it's number 2. So that means most of their data, that's 50% of the data, falls between here. So the scores for test 1 is more spread out than the scores for test 2 because only 50% fall within 10 scores and then the rest of it's everywhere on the outside. So this is pretty compacted in the middle. So you can see it spreads way out. So the spread for the scores for test 1 are more spread out than test 2. So the range 91 minus 62, if we're filling this in, is 29. Interquartile range for the test is 10. And then the range 91 to 71 is 20. And the interquartile range again is 18 of the second test. So the tests are more spread. Seems like a small blank for that, but more spread out than the range. Interquartile range is, and that's just calling out vocabulary again, because like I mentioned, I think that might be one of the only portions of this that should be new. So that's Q3 minus Q1 equals IQR. And that is 50% of all data, because that's that whole box in the middle of your box and whisker. So 50% of all the data is within your IQR. So now that you can make finite assumptions between this data, or like conversational pieces, the video, I believe it's either today or tomorrow, we'll really discuss it. I think it's a Khan Academy video that talks about, you can't give like answers. Like I know there was this many 82 scores, but I know that 50% of the people in this class on this test scored between this and this. So that's why IQR matters, because that is a big chunk of your data. All right, so box and whisker plots on Team Red and Team Green. So the box and whisker plot below represents the scores of two baseball teams throughout an entire season of the game. Which team had a wider range of scores during the season? So a wider range. So your range for Team Green is 105, because they're counting. It looks like everyone is 5, 100, 105, 110. So again, that goes back to making sure, sorry, this page is crooked, that you're paying attention to the way it's numbered. Seems super silly, but again, we get real excited and we're used to 1, 2, 3, 4, 5, or 5, 10, 15, 20, and it's not always like that. So we are counting these by 5. So that's 105 and that's 60. So green range is going to be 105 minus 60, which should give us 45. And just for conversation, let's go ahead and do our IQR for practice. So IQR is going to be 95 minus 75, which is 20. So 50% of our data falls between 95 and 75 for our green team. And then our red team, this is one I probably should have changed colors. Red team, so I have 70 and looks like about 110. So range is 110 minus 70. So my range is 40. And then my IQR is between 80 and 105. So 105 and 80, which is going to give me 25. So 25, between 25 is 50% of our data. Between 20 is 50% of our data. So this is more compacted, though it has a larger range. So all outside of 95 and 75 is 50% of the other 50% of our data, but a lot of it falls in between there. So that's a pretty good conversation about what's happening in here. So as far as which team has a wider range of scores, so wider range of scores is going to be Team Green. And then we have our range over here, range here to fill it in. So range for Team Green is 45. Range for Team Red is 40. Got 5 more minutes, and we'll keep going unless somebody tells me otherwise. Got one more example with lots of questions. So not knowing what this is, but it is numbers and it is a box and whisker plot, we're going to compare and discuss all the parts. What is the median of each data set? So median, sometimes I like to do, so this is our min, max, Q1, Q3, median. So min, max, Q1, Q3, median. And again, that's not required. That's one of those things that, especially when you look at a list of questions below it this long, to make sure you don't accidentally grab the wrong number. It's just trying to get you present and making you looking at this question and thinking about what's happening right now, right here. So median, that's our middle point for each data set. So median for A is going to be 70. Median for B is going to be 70 as well. So they're the same. Which plot has a lesser range? Which one has a smaller range? So range A is going to be 100 minus 50. So range A is going to be 50. Range B is, again, our max is 100, but it goes all the way down to 40. So then our range B is 60. And I'm not sure what the then part is. Oh, so then the answer would be range A is the smaller range. So less spread out, less range. So all the numbers fall between 50 and 100. So which plot has a greater interquartile range? So I'm going to say it again. Interquartile range is Q3 minus Q1. So A, Q3 is 80. And I'm going to subtract Q1, which is 65. And again, this is 40, 45, 50, 55, 60, 65, 70. So each little tick mark is 5. So for A is 15. B, our Q3 is 85. And our Q1 is 60. So it's going to be 25. So which one has the greater interquartile range? That's going to be B, which means that data is more spread out, because that means 50% of the data falls between a larger chunk. So the spread of B is going to be greater. Not necessarily, in this case, the range as well, because it goes from 40 to 100, but the spread out number of numbers is going to be greater relative to your IQR. What is the upper quartile? So upper quartile is that Q3 that we were talking about. So that is Q3. Upper quartile is Q3. So for data set A, Q3 is going to be 80. For data set B, is 85. What is the lower quartile? And that's going to be your Q1. And that's the left end of your box. A is going to be 65. And B is going to be 60. What is the least value in plot A? So that's going to be your minimum in plot A. It's going to be a 50. What is the greatest value, which is going to be your max or your upper extreme? I'll write that here too again, because I can't, depending on what program, what teacher you have, and all those fun things, these words are all used interchangeably. So max and upper extreme are the greatest value for B. So it's going to be 100. Which plot has the larger range of data? So again, we're talking about B. The same question as B, but instead of lesser range, it's the greater range. So it is going to be plot B has the greater range. So plot B has the greater range. Now, percent of data. This is the one I want to make sure. So we have 25, 25, 25, 25, 25, 25, 25, 25. Even though they look very different, between Q1 and median is 25% of your data always. Between median and Q3 is 25. Q3 to max is 25% of your data, and Q1 to min is 25% of your data. And hopefully that makes some sense. Like when we were crossing out in our other example, the example earlier, where I was crossing out to find the median, and then I crossed out from median to max to find your Q3, it's the middle number. So we split that list of data into 4 chunks, which is why your box and whisker looks like 4 chunks. So what percentage of data in plot B is between 60 and 85? So if I'm looking at B, between 60 and 85, that's Q1 to Q3. That's 2 sections. So it is going to be 50%. What percentage of data in plot A is greater than 80? So plot A, 80. So this one, and greater than means to the right. It's 25%, because there's only one section of our 4-section box plot. What percentage of data in plot B is greater than 60? So I'm going to plot B, and I'm going to 60, which is right here. And greater than is this way, where the numbers are getting bigger. Greater than, so it's going to be 75, because that's 3 parts, 1, 2, 3/4, so 75. And then for our last one, last one about percent. What percent of data in plot B is greater than 60? Oh, did I answer that wrong? I skipped a question, didn't I? Whoops, sorry guys. So 75 actually goes here. What percentage is less than 65? Less than 65 in A. So if I go up to A, this is 65, and less than is this way. So the actual answer is 25%. Sorry. I didn't type this out, and they're really close together as far as trying to talk with no response. So what percentage of data in plot A is less than 65? Go to 65, and less than is 25%. What percentage of data in plot B is greater than 60? So plot B at 60, and greater than is the 3 parts, 75. Are any of the data points in plot A or plot B outliers? Outlier, you're going to get into in the next couple of days. It is actually just a point that is super, super out of the norm. And you're going to learn how in Desmos to plot it and see it, like so you can actually decide, because some lists of data, it's very obvious. And then other lists of data, it's very not obvious. It's just slightly out of the norm. I always used to call it the sleepy kid in class. So you're in a classroom of 25, 20 kids, and you're having a test average, and your teacher tells you that if the whole class scores, here or above, we'll skew the test, or we'll, not have homework this weekend. And there's always that kid in the back who falls asleep 5 days out of the week or 3 days out of the week for half the class, and they take the test, and they're not going to score a 50 or above or whatever the number is, but everybody else in the class has really enjoyed the lesson and they scored 60. So they're that super low score that took down the class average. And then of course, there's that person in every class as well that no matter how hard the content gets, whatever class it is, math or English or science or history, they just nail it. It's like they sleep and absorb information when they're asleep. So that is an outlier as well. Like if you have a general class of you and your friends and you all do about the same amount of work, and then there's that one kid that sits in the corner that just gets everything right. So your class average is 50 maybe, and they scored 100 on the test. Those are outliers. The differential part that doesn't really match the group. Those are outliers. Which plot gives more predictable values? So you can kind of discuss this a couple of different ways. As far as predictable values, you could discuss probably plot A, because everything is a little closer together. So if you were to throw a dart at a dartboard and all the extra stuff on the outside sort of went away and you were throwing, then you're going to get closer to the target. If you have a lot of extra space to throw your dart to, it could get further from the target because you have extra space to throw it on the dartboard. So thinking about plot B, there's a lot of data between 40, you have 60 different points you could hit that were still in plot B. So still part of this conversation of data for B. In A, your conversation is only 50. So you're only picking numbers from 50 to 100. So you're probably more likely to hit an accurate conversational number. And this data is to use, it's probably one of the math things that you're going to learn that really does live in society pretty well in market research and all sorts of things like that. I'm going to post a video probably next week in part of our review where they really apply all these vocabulary words to day in, day out things, so you see why they matter. So that wraps up what I've got printed for the moment for you guys today. So if you have questions, go ahead and shoot them to me. If you need to email me later, that's fine too. And I apologize, we went over about 5 minutes.